Hello Snowflake data engineers. Welcome to section introduction for hybrid tables, in which we will discuss the topics we are going to cover in this section. We will begin by discussing what are hybrid tables, and after completion of this topic you will understand what hybrid tables are and what they are designed for. This will be followed by a lab exercise in which we will create two hybrid tables and add constraints to them during table creation, insert data into them, create indexes, and test hybrid table functionality. After completion of this topic, you will be able to create and manage hybrid tables. Next, we will discuss the concept of Unistore. And after completion of this topic, you will understand what Unistore is and what Snowflake means when it says Unistore. We will discuss Snowflake architecture with respect to hybrid tables. After completion of this topic, you will understand changes to Snowflake architecture due to hybrid tables. Hybrid table discussion would not be complete without discussing limitations of hybrid tables. Hybrid tables do have a lot of limitations, and after completion of this topic you will know if there are any limitations that are a deal breaker for you when you decide if you should use hybrid tables. We will finally wrap up the section with a summary of the topics. This will reinforce the most important points we covered in this section, and you can come to the summary for a quick refresher in case you don't want to spend time going through all the topics. What is a hybrid table? Hybrid table is a Snowflake table type that is designed for OLTP or transactional applications. Most of you already know what a transactional application is. However, for the benefit of those who do not, let me give you an example. If you went to a bank ATM and withdrew money from it, you created a transaction which is handled by the banking application. And this banking application is a transactional application. Transactional applications need low latency and high throughput. You might wonder, why do transactional applications need low latency and high throughput? And the simple reason is because you do not want to be waiting at an ATM for 15-20 minutes trying to withdraw your money. Transactional applications need to be quick and need to complete the transaction quickly. Snowflake hybrid tables provide low latency and high throughput and can be used to build transactional applications. On the other hand, non-hybrid Snowflake tables are not suitable for transactional applications because they do not have the necessary low latency and high throughput. Time to talk about hybrid table features. You can define a primary key on a hybrid table. In fact, they are mandatory. You cannot create a hybrid table without a primary key, and very importantly, this primary key is enforced in hybrid tables. Unique key constraints can also be defined on hybrid tables. They are optional and you are free not to define them if you do not have a use case for it. Referential integrity constraints can optionally be defined on hybrid tables, which ensures that data between parent and child table do not go out of sync. We can create indexes on hybrid table to improve select performance when using the where clause. Let us review the syntax for creating a hybrid table. We can create a hybrid table by using the hybrid keyword in the create table statement. Let's jump into a lab exercise in order to create and experiment with hybrid tables. I'm going to start off by creating a database called Unistore. You can create a database with any name. Unistore is what I have chosen. You can choose whatever you like. I'm going to create a schema called hybrid. Again here, hybrid is the name I have chosen. You can choose any name you like. Let us go ahead and create our first hybrid table. The important thing to remember when creating hybrid table is that hybrid tables need to have a primary key. If the primary key is not present, the hybrid table creation will fail. Let me remove this primary key keyword from here and let me try and create the hybrid table. As expected, the creation fails because the primary key is not available. So I'm going to put the primary key back and I'm going to create our first hybrid table. The hybrid table has been created. If I want to see the hybrid table, I can do show hybrid tables and it will show me the hybrid tables that are available. I do have the option of using show tables instead of show hybrid tables, which will show me the tables. The difference between show hybrid tables and show tables is that with show hybrid tables, only hybrid tables will be displayed, whereas with show tables, all tables including hybrid tables will be displayed. If you want to use information schema, you can go there and look for hybrid tables. The table type over here will be listed as hybrid table, and that is how you can locate hybrid table. Let us go ahead and insert rows into the departments table. I want you to pay particular attention to the department ID values. They start at 10 and they go up to 90. We are going to need this information later when we populate the employees table. Let me go ahead, select all these rows and insert it. I have inserted rows into the department table. Let me go ahead and select data from departments in order to make sure that it is appropriately populated. As expected, I have the rows that I inserted, so we are good in terms of the insert statement. Now it's time to create our second hybrid table, which is the employees table. The employees table, as you can see on your screen, is a little more complicated. In addition to the mandatory primary key, we also have a unique key constraint, a foreign key in which the department ID references the department ID in the departments table, and I also have an index on the hire date. Let me go ahead and create this table. The employee table has been successfully created. It's time to insert a couple of rows. I need to make sure that the primary key values are not violated, and also that the unique constraint are not violated and the referential integrity constraint is honored. Now, department ID 90 is what the department ID is for these three employees, and I do have department ID 90 in the departments table. So I expect these rows to be inserted without any issues. The insert is complete. Let me go and select data. As expected, I see 3 rows that have been inserted, which shows that the insert statement completed without any issues. It's time for us to test the primary key, the unique key, and the referential integrity constraint to check if they are actually enforced by Snowflake. I'm going to start off by trying to introduce a duplicate primary key. In this particular case, employee ID 100 was already inserted with Stephen King. I'm going to attempt to reinsert this with 100 for Alexander. Let us see what happens. As expected, it threw a primary key error, which is good because that is what we wanted. I reversed it back to 103, and I'm going to now attempt to insert Alexander in. That's a success. I'm going to select data just to make sure that Alex is present in the target table. Next, I want to check the unique key constraint. The unique key constraint was on the email address. Now, Bruce has an email address of B. Ernest, and I'm going to replace it with the email address of Alexander. What would happen in this particular case is that it would attempt to insert a duplicate email address, and ideally what should happen is that this insert statement should fail. As expected, duplicate key violation was presented to us. Alexander's email address is already present in employees table, and hence it prevented it from being reinserted again. I'm going to have to reverse that, and let me now attempt to insert this row. Once I fix the duplicate issue, I was able to insert the row successfully. I am now going to test for referential integrity constraint. 105, David D. Austin. The primary key and the unique key constraints are not getting violated by these values. However, I'm going to change the department ID, and I'm going to put department ID 100. We inserted department IDs from 10 to 90. Department ID 100 is not present in the departments table. I'm going to run this insert statement, and I'm going to see if it is going to error out. It did. It tells me that a foreign key constraint has been violated, which means that I need to insert department ID 100 in the departments table before I can make this insert. So what we see is that the referential integrity constraints in hybrid tables are enforced as they should be. Let's move on to indexes. If you look at the employees table, you remember that we created an index on the hire date column. Indexes help in fast retrieval of data in the where clause of a select statement. What we want to do is that we want to see all the indexes that exist on the table. I'm going to do that by doing show indexes. When I do show indexes, I do see the hire date index on the employees table. However, in addition to that, I see several other indexes that are listed that I did not explicitly create. The reason for this is because when we create a constraint in Snowflake, Snowflake automatically creates an index on it. So when you create a primary key, or you create a unique key, or you create a referential integrity constraint, an index is automatically created on it, and that is why you are seeing several indexes that are associated with the constraints. Now I am permitted to create new indexes after table creation. For example, I am going to be creating a new index on the phone number column. The index was successfully created. I can run the show indexes to verify the creation was successful. I can see the new index phone number listed here. If I want to drop the index, I can simply use the drop index name and the index can be dropped. I am also allowed to create composite indexes by including more than one column. In this particular case, I am going to create an index on the first name and the last name. As you can see, I have created a composite index. It's time to move on to talk about constraints. When we create a unique key constraint or a referential integrity constraint, there may be times when we want to drop these constraints for whatever reason. It could be data loading or something else. If we want to drop the constraints that we have created on our table without recreating the table itself, we need to locate the name of the constraint, and we can do that by going to the information schema table constraints. If you look at this table carefully, we have the constraint name, we have the table name, and we have the constraint type. And so if I wanted to drop the unique constraint on the employees table, I could come here, copy the constraint name, and put this into an alter table drop statement and run this to drop the constraint. The statement was successfully executed. I'm going to go back. As you can see now, the unique constraint is no more visible, which means that the alter table drop constraint command dropped the constraint. So I can manage constraints post table creation if need be. Similarly, if you want to find referential integrity constraints, they can be found in the referential constraints view. Out here we see the constraint name. I can simply take this constraint name and put it in the alter table command and drop the constraint if that is my need. What is Unistore? The word uni means one. Unistore means one store. This will make more sense later in the video. There are two types of workloads a database can encounter. It can encounter an analytical workload, which can be thought of a data warehousing type of workload with facts and dimensions, or transactional workloads, which would be the banking application we discussed with the ATM cash withdrawal example. Different databases are used for analytical and transactional workloads, as some databases are more suited for transactional workloads and some are more suitable for analytical workloads. For analytical workloads, you could consider databases like Teradata or Vertica, which perform well on analytical workloads but would fail miserably on transactional workloads. For transactional workloads, you could consider databases like Oracle or SQL Server, which are excellent fit for transactions, however are not very great with analytical workloads. So the question is, what is Unistore? Unistore is Snowflake's bold claim that Snowflake Cloud Database with hybrid tables is well suited for transactional workloads, and Snowflake non-hybrid tables like permanent or transient tables are well suited for analytical workloads, making it a single store, Uni, for processing analytical and transactional workloads. Snowflake hybrid tables and non-hybrid tables can be created in the same database and can also be joined with each other. Since both types of workloads can be handled by Snowflake database, Snowflake calls it Unistore, a single store that can handle both analytical and transactional workloads. Snowflake Architecture and Hybrid Tables. Snowflake architecture has undergone changes due to the introduction of hybrid tables. While the changes do not affect the way we work on Snowflake, we need to understand the changes because it will help us better design our tables. To begin with, let us talk about what has not changed. No change in the cloud services layer, which means we will continue to access Snowflake the same way as we have been doing so far. No change in the query processing layer, which means that queries will still be processed by virtual warehouses and they will consume the same amount of credits as would have been needed for a non-hybrid table. With regards to what has changed, Snowflake has introduced row store to store hybrid table data in a row-oriented manner to support transactional workloads. This is needed as columnar storage that is used in non-hybrid table is not suitable for transactional workloads and cannot meet the latency and throughput requirement. These row-oriented data benefit from secondary columnarization, which means that the row-oriented data is then restored in columnar format to speed up joins with non-hybrid Snowflake tables. Hybrid tables consume more space than non-hybrid tables, which makes sense since the row-oriented data has to be restored in columnar format for joins with non-hybrid tables, and this extra storage adds to the space consumed by the hybrid table. Hybrid table consume additional serverless credits since compute is needed to turn row-oriented data into secondary columnar format. This will happen in the background and we do not have to do anything explicitly to achieve it. Indexes when created consume space as they should because like all other databases, indexes are stored externally to the table to improve select performance. Limitations of hybrid tables. Hybrid tables are exciting. However, there are several limitations and we need to try and understand them. You cannot create cluster keys on hybrid tables. Continuous data protection features like time travel and failsafe are not allowed. Cloning, which depends on time travel, is not supported. You cannot create dynamic tables on hybrid tables. You cannot create materialized views on hybrid tables. Query acceleration service, which provides serverless compute, cannot help with queries on hybrid tables. Search optimization service, which is used to improve point lookups, is not supported on hybrid tables. Since we have indexes on hybrid tables, this should not be an issue. Data ingestion using Snowpipe or creating of a stream on hybrid tables is not supported. We cannot use hybrid tables and add it to a share. Periodic rekeying and tri-secret encryption, which are encryption-related services, is not supported in hybrid tables. Collation support is also absent for hybrid tables. In the future, Snowflake might add support for some of these unavailable features, but for now, these are the limitations that we need to work with. Let us summarize what we have learned in this section. Hybrid tables are designed to support transactional applications and workloads. Hybrid tables must be defined with the primary key and the primary key is enforced. Hybrid tables support unique key and referential integrity constraints, though they are not mandatory. Hybrid tables support indexes, which can help improve select performance. Hybrid table data is stored in row-oriented format for transactional performance. Snowflake Architecture has added row store to accommodate hybrid table data. Unistore means a single data store that can support both analytical and transactional workloads. Hybrid table row-oriented data is restored in columnar format for analytical workload performance when joining with non-hybrid tables. Hybrid tables consume additional storage and serverless credit for table maintenance. Hybrid tables and non-hybrid tables can be created in the same database and they can be also joined together. Hybrid tables suffer from several limitations including lack of time travel and failsafe. Hybrid tables can be created by using hybrid in the create table statement. With that, we conclude this section. If you have the time, please join me in the next section.